please welcome to the stage Head of Investor Relations at Village Global, Olga Sergievich.
In today's conversation, she will tell us more about possibilities of electric medicine. But first, let me start with a few words about Meredith. She is an embodiment of the core values of the Summit community. She is an inventor, founder, and a builder whose intellectual curiosity and the desire to make the world a better place has led her to a lot of diverse endeavors, as different as researching life on Mars and conducting experiments in zero gravity while at NASA, to the invention of U-beam, a long-range wireless power system, to serving on the board of directors of the J. Craig Venter Institute, a leading genomics institution. She's an inventor on 30 patents, and as you can imagine, she has received a lot of awards in her career, including being named to Fast Company's Most Creative People and Vanity Fair's New Establishment. But one of my favorite ones is the Elle Magazine's Genius Award, which I encourage all of you to ask her later at the drinks. Without further ado, I pass the mic to Meredith Perry.
Hello, everyone. Oops, I guess I should turn the presentation on. Okay, so how many of you guys know what neurotech is? Oh, wow. Okay, an educated audience. Do any of you guys own a neurotech device? Okay. All right, well, my hope is that at the next Summit at Sea, all of you guys are going to be owning a neurotech device. But okay, so I'm going to keep this short and sweet and mostly for a general audience. But if any of you guys want to dive in deeper on any of these topics, please find me afterwards. Okay, so let's talk about healthcare in 2023. In 2023, healthcare is reactive. It's slow. It lags far behind technology. It's based on averages and not on individuals, and it's oftentimes ineffective. In 2023, we have sensors that are monitoring and anticipating when your car will need new brake pads, or when your refrigerator water filters should be changed, or even when your fridge will be empty. But when it comes to our health, the approach is almost entirely reactive. We find out about problems only when they become large enough for there to be symptoms, and only after we feel sick do we actually go to a doctor to then perhaps take a pill. This costs us valuable time that could be used to start treatments early, and typically, the earlier that you can treat someone, the better the outcome. The fundamental concept of medicines themselves have changed little throughout human history. Medicines have long been substances that are either applied, ingested, or injected to treat disease. And this pharmaceutical-based approach still faces many of the same challenges it has for thousands of years. It's very difficult to get a drug to act specifically at the right place, the right dose, and the right time. And as a result, many drugs lack efficacy or cause side effects that can range from annoying to life-threatening. And even with the advent of gene therapy, machine learning, and AI-driven drug development, 90% of new drugs still fail in the clinic and never make it to market. The side effects of drugs limit their usefulness and make their use a trade-off. So how many of you guys have ever taken allergy medication and felt drowsy as a result? The same active ingredient for allergy medication is packaged and sold separately as an entirely different product as a sleep aid. But 2 for the price of 1 doesn't really help you here. When you're trying to stop an allergic reaction, you're not also trying to fall asleep. And when you're trying to fall asleep, you're not also trying to suppress your immune system. But the pharmaceutical approach to medicine is to target molecules in the body chemically with other molecules. But the body reuses molecules for different purposes in different organ systems. This results in frequent and sometimes debilitating side effects that include everything from excessive flatulence to heart attack, stroke, and even death. I'm sure you guys have all watched drug commercials at the end of on TV where they speed through a list of all the different ways the drug can kill you. And now you have an understanding of how literally any drug causes a side effect. Drugs are also dumb. The brain acts on the time scale of milliseconds, while drugs act in minutes to hours. Pills can't change their dose based on real-time physiology. And because pills are ingested, they need to go through your entire body to hit their target. They literally go everywhere. So for an example, an antidepressant doesn't do you any good in your toes, but it ends up there anyway. This makes a chemical drug very difficult to control and personalize. They're also typically given after disease progression, and the drug itself can't know when the condition is resolved, so it can stay in your body for much longer than you actually need it. And drugs are also chemically fixed and unable to change without years of laboratory and clinical research. So what if you could make a drug without side effects? We'd probably take them to treat every minor ailment. I know I would, because why would we not be the most optimized versions of ourselves if there were no consequences? In an ideal world, medicine would be proactive. It'd be targeted, effective, and it would have no side effects. For this to happen, we need to continually monitor our biology and health to be on the watch for changes, as change can often be an indicator that something is off. We'd also need to be able to diagnose issues as soon as they occur, or perhaps even predict that an issue might occur before it happens. And finally, an ideal system would customize the treatment protocol for the individual based on their biology and treat the issue effectively. So how do we reach this idealized state? Electric medicine. Electric medicine is a completely new category of medicine that's emerging that leverages new advances in signal processing, algorithms, hardware, AI, and machine learning, as well as advances in our understanding of the brain and the nervous system. Through continuous biological monitoring, electric medicine can diagnose issues before symptoms appear, enabling early intervention and personalized treatment. And with what we call an electric drug, we can finely tune the dosage to an individual's specific biology. The dosage can be modified based on the individual's real-time response, unlocking a new era of precision medicine. Electric medicine leverages the fact that the brain and the nervous system is thousands of miles of sensors and actuators spanning every organ, patch of skin, and blood vessel in our body, making it the most sensitive instrument to detect and react to internal and external threats to our health. By interfacing with the brain and nerves, we can detect pathological changes as they happen and act quickly and specifically to intervene. So with electric medicine, we can use new kinds of wearables like an EEG to continuously monitor the body's biometrics. And within these wearables, we can use AI and machine learning to immediately detect change in the body and diagnose when something goes awry. And with something called neuromodulation, which I'll explain in a second, we can immediately treat those issues directly. And finally, to maximize efficacy, we can adjust the treatment in milliseconds based on the body's real-time response. So let's talk about neuromodulation. This is basically the active ingredient of electric medicine. The brain is our master organ. It's the motherboard of the body. It controls electrically through nerve impulses and chemically through hormones. Activity in the brain can be measured with something called an EEG, and this can be worn externally on the scalp. And this activity can be visualized as what's called a brainwave. Brains can also change in response to environmental stimuli, and that change can be seen in the EEG, and this is why people refer to brains as plastic. By stimulating the brain non-invasively with stimuli like sound, light, vibration, or even electricity, we can modulate brainwaves and therefore modulate specific body functions, allowing replacement of some drugs with computer programs. We call this an electric drug. So while pharmaceuticals act by altering brain chemistry, which affects how the brain processes information, electric medicine works directly on brain signals themselves, modulating electrical impulses that the nervous system uses to encode information. And as you can see here, the pathway to an effective response is much shorter and much more direct with an electric drug versus a chemical one. So I run a company called Elemind, and we are at the forefront of electric medicine. Elemind is wearable neurotech that reads the brain and intercepts it in real time. It guides the brain through neurostimulation and ultimately changes behavior. Elemind's technology is like noise cancellation technology, but for your brain. So similarly to how your AirPods can cancel out loud noise in your environment and make it appear quiet, Elemind can do something similar with your brain. So remember before how healthcare typically moves on the scale of hours and days, but the nervous system operates on a scale of milliseconds. To address that, we've broken new ground with an algorithm that instantaneously computes the phase of a biological wave, and a biological wave can be a brain wave or a gastrointestinal wave or a heartbeat, and we can stimulate the brain 100 times faster than human reaction time, delivering treatments at the exact moment when they can have the greatest impact. And similarly to noise cancellation technology, this allows us to interfere or augment biological rhythms in real time to modulate them in a predictable way, enabling precise control of biological processes. So this whole concept, this is the foundation of Elemind, and this can be applied to many applications. But the first problem that we're attacking is sleep. This is our Tesla Roadster. We've developed a headband that can rapidly induce sleep using only sound waves and also boost the time that you're in deep sleep, which is associated with better sleep quality. So let me explain. Different brain states are characterized by different kinds of brainwave activity, and this can be measured on the scalp with an EEG. So this is what your brain looks like when you fall asleep. Your brain waves naturally shift from high frequency alpha waves to lower frequency theta waves, and then even lower frequency delta waves when you're in deep sleep. Elemind's technology uses acoustic stimulation, just sound, to suppress the high frequency alpha brainwaves that keep you up and boost the low frequency brainwaves that are associated with deep sleep. The sound stimulation is played at very specific points in time relative to your own brain to interfere with your alpha waves in such a way that they're effectively canceled out. So again, you can really think about this like noise cancellation, but for your brain waves. And by doing this, we push the brain to sleep rapidly. So we studied people at UConn and showed that with Elemind's technology, they were able to fall asleep 15 minutes faster than normal. This is 2 times faster than the leading sleep drugs like Ambien and Benadryl, but without any of the negative side effects. Another example of what our technology can do is to help people with physical tremors. So there's a neurological condition called essential tremor, or you might be familiar with people with Parkinson's who shake uncontrollably, and that shake is called tremor. So we did an experiment where we used stimulation to cancel out the physical tremor, similarly to how we cancel out alpha waves in the sleep example. So I'm about to show you a video of a side-by-side comparison of the same person with Elemind stimulation on the right and without Elemind stimulation on the left. And before you watch this, just know that this was the first time that we did this, and it's just an early prototype, and this was only after 30 seconds of stimulation. So on the right is with Elemind stimulation, and on the left is without Elemind stimulation. And this was just after 30 seconds. So we're seeing pretty dramatic results in only that short period of time, but we expect this to improve greatly with longer stimulation times. And ultimately, something like this could be worn on the wrist, like an Apple Watch, and discreetly stop tremor for people with this kind of disease throughout the day. And interestingly, this is the same kind of effect that people get with something called deep brain stimulation, which involves 2 massive electrodes and a battery implanted surgically in your chest. So the fact that we can achieve the same result without surgery is a really big win for us. Neuromodulation has actually been around since the 60s and has been effective to an extent, but all they really do is deliver current from a battery into the brain or the heart or the nerve. So a pacemaker, for example, is something that you might be familiar with, as well as the deep brain stimulator, as I just mentioned, or even like a spinal cord stimulator for people with severe pain. But these devices have largely gone unchanged, and they aren't smart. They don't respond to feedback from the body, and so use cases for these are limited. But advances in both technology as well as our scientific understanding of the brain and the nervous system has opened the door for significant advances in neuromodulation, and that's where Elemind comes in. So here's a third example of how Elemind's technology is being used in the field today. So our partners at WashU and McGill did a study where they combined Elemind with anesthesia and saw that the combination puts subjects in a much deeper level of sedation. These subjects were able to tolerate 2 degrees higher temperature against their skin with Elemind than without. This means that anesthesiologists could potentially lower the dose of anesthesia given to their patients, which would lessen the hangover effect that's often associated with taking those drugs. I actually find this example particularly interesting because when someone is unconscious, it's a lot harder for there to be bias, and it minimizes the possibility that this was a placebo effect. So other applications for this kind of technology extend far beyond sleep, tremor, and anesthesia. In theory, any neurological condition can be controlled with an electric drug. Things like electric Adderall for improving focus and attention, or an electric drug that could stop a seizure, or even induce hypnosis to allow people to lose weight or perhaps quit smoking. Outside of Elemind, we see other companies using light and sound stimulation to remove amyloid plaque from patients with Alzheimer's. The possibilities of electric medicine are vast. Electric medicine will allow for rapid diagnosis of issues through continual brain monitoring and AI. Treatments will be precisely tailored to the individual based on their biometrics at the time of need, unlocking a new era of precision medicine. Thank you guys for your time, and I can't wait to do drugs with all of you.
Thank you, Meredith. Hearing from entrepreneurs like you makes me optimistic every day. So let's start with how did you come up with the idea for Elemind and how did you get started?
It's a little bit of a bizarre story. About 10 years ago, when I was in college, I had an obsession with autistic savants, and I looked into how their brain was perhaps different from my brain. I'm not autistic, and I looked at someone else's research where they were using what's called transcranial magnetic stimulation to suppress the brain of a non-autistic person. And when they did that, they actually showed that the person would achieve savant-like qualities through suppression. So that got me thinking about how you might be able to use that kind of technology as a cognitive enhancement tool for the average person. And how could we package that as, an electric drug? So I was also interested in trying to figure out how you could experience a lot of different kinds of chemical effects without needing to be locked into a time period based on the half-life of a drug. Anyway, so I reached out to my friend who's now my co-founder, Dr. Ed Boyden, who's one of the leading neuroscientists at MIT, and he had already developed this algorithm that allows you to compute the phase of a biological wave in real time. And they had shown some early research with tremor, and we decided to combine forces, and the rest is history.
One of the most intriguing ideas that you sometimes talk about is the App Store for the brain. So tell us more what that is and when can we expect for it to become a reality?
So, the grand vision for Elemind is to ultimately become an app store for the brain, where we have, real-time biological monitoring. We're detecting change in your biology. We're diagnosing issues as they arise, and then we're treating them in real time. And but you might also be able to download a drug in your digital pharmacy, so to speak. And that's how we think about an app store for the brain. So we'll be able to push features as we do new research through the app. It's a firmware update. And that's how you can access your drugs in the future, hopefully.
And what brain superpower would you like to have that you currently don't?
I mean, all of them, but maybe perfect memory. Although, we have our computers around us all the time right now that maybe we can store most of that there. I'd like to be able to compute faster in my brain. Yeah, I think that'd be better.
That's a good answer. And you are an inventor on 30 patents. Are patents like children? Do you love all of them the same, or are there any that stand out in your memory?
Oh, no. There's definitely like core patents versus, there are definitely some key patents that are critical to the value of the company versus others.
And tell us more about your vision for the future of medicine, and what role can Elemind play within that? My
vision for the future of medicine is one that I think will be able to get to hopefully in my lifetime, but I don't think the technology for it exists today. But I would ideally like people to be able to monitor their entire bodies continually and look for changes. So, instead of needing to go get a scan, once every 6 months or once a year or something like that, which is something that most people don't do anyway, maybe one day people can shrink that kind of technology and have it as like an implantable device in your body to be continually monitoring changes in your blood, changes visually if there's some sort of like tumor or something like that. That I think is the ideal situation. Craig and I were talking about yesterday how the cure for cancer is actually prevention. And so if we can just get in as early as we possibly can, that's ideal. And Elemind is not looking at the whole body. We're just looking at neurological issues. So Elemind will play a role in that for a part of the body for a subset of diseases.
In the last couple of days, we heard a lot of really interesting conversations about science more broadly and all of the exciting recent developments. And I think we all agree that it's really important to inspire young generations to study science. What part of your education led you to learn how to be an inventor?
I don't think any part of my education led me to being an inventor, but there's certain things that I learned about that really fucked with my mind in bizarre ways and made me very curious about the world. And that was when I was in 5th grade, my grandpa told me what a black hole was, and that blew my mind. Because, when you're 10 years old, all you do is roll around in the playground with your friends and then you get introduced to the concept of a black hole, and your whole perception of reality is shifted. But yeah, so I guess learning about space in particular made me realize that nothing in the universe makes sense, and therefore nothing really matters, and you might as well just ask a lot of strange questions and do a lot of strange things and just see what you get out of it. I know that's a weird answer, but that was true for me.
You got to work on a lot of interesting things in your career. Why is it important to explore possibility of life on Mars, in your view?
I think that we as humans with the intellectual power to do so should, because, a basset hound can't. I think, even though the search for life elsewhere doesn't make anybody money, it expands our understanding of the world around us, which we have so little understanding of. And I think we have a duty as humans to do that.
And are you a techno-optimist or a techno-pessimist?
Definitely an optimist, yeah.
And what are some of the areas that make you particularly excited or optimistic about the future? And it doesn't have to be just healthcare or medicine. You can go more broadly, but what's the most exciting ones for you today?
I mean, everyone's obsessing about like ChatGPT. I mean, I'm pretty excited about it. It's helped me a lot. I mean, there's obviously like scary things that can happen with AI and things like that, but I think it's ultimately going to become a tremendous tool for a lot of people, including me.
Are you currently using ChatGPT in anything at Elemind?
Not in our product, but I use it daily for my own work. Yeah. It reviews contracts for me and saves me thousands.
I think we have a question.
Yes, great presentation.
Thanks.
I was curious because I've used the news headband and hacked around with it with API. I find that the over-the-head sensors tend to be quite fragile. I know that there's a couple of companies exploring subdermal sensors for tracking. I was curious to hear about the distinction between over-the-head skin sensors and subdermal, which one you're pursuing.
Yeah, I know exactly what they use. It's called Intexar, and it's very fragile material. It can crack after like 3 months, and once you get a crack in that material, then your circuit is like broken, and so that's why that's happening. Also, if you put rubbing alcohol on it, it destroys the sensor. And they actually have on their website, I don't know why I'm talking about Muse, but they have on their website that you should use alcohol on it, and that's actually, you shouldn't do that at all. Yeah, so their sensors don't work for a very specific reason. We use conductive rubber, which is pretty robust. We have 6 seconds, I think.
Yep. Let's go right there in the middle.
One quick question. When will it be available and price point? And then one other one, is it similar to neurofeedback?
Neurofeedback requires the person to be active. You have to be an active participant and decide that you want to, follow instructions, which is very effective for some people. With Elemind, you don't have to be an active participant. Similarly to a pill, you just let it happen to you. I fundamentally believe that humans are extremely lazy, including myself, and we should try to meet people where they are. And so we think this neurostimulation approach is active. It does the thing for you. I'm not going to say when it's available. I've made that mistake in the past and blown past those deadlines. But you can sign up for early access if you go to that QR code or just email me. And we're price testing right now, so I'm not exactly sure how much it's going to cost, but I'll ask you privately later what you think of the price that I spit out.
Okay, perfect. Thank you.
Cool. Thank you, guys.